Buongiorno a tutti.
Good afternoon, ladies and gentlemen. My name is Damiano Frosi, Chair of Osservatorio Contract Logistics. On the occasion of this fair, we started collaborating with Intralogistica, and yesterday morning we had the first workshop organized by the Observatory, about 100 attendees. Today we have fewer attendees, but still the topic we'd like to discuss today is very interesting, which is the evolution of logistic buildings between sustainability and the digital domain. Andrea Fossa is here with me, and actually he literally sits on top of me because he is the scientific director and founder of the Observatory and also CEO at GreenRouter, and I'm sure that he's going to say a few words afterwards. And we'd like to show you some results of a study conducted by the Observatory, together with two other guests of ours. Sitting to my right, Fabio Brisichella, Facility Manager at Brivio and Viganò, and Andrea Martini to my left, Managing Director at Trilux, Italy. And they will be sharing with us three case histories during the second part of our presentation. So we're going to spend together approximately 1.5 hours. So I'm going to start out with an introduction about the Observatory, Osservatorio Contract Logistics at Politecnico. I will be focusing on Logistics 4.0, so the digital domain, and we'll tell you where we are at this point in time. And then we're going to be talking about the evolution of logistics networks, evolution of design choices, energy efficiency, and climate impact. And Andrea Fossa will be taking the floor later on. So a few words about the Observatory. And for those of you who don't know us, well, the Observatory turned 12 this year. It was created in order to set up some sort of a permanent discussion table, and so that the different providers, software and hardware providers, supply chain managers could converge towards the Observatory in order to pursue a common goal, that is to say, to think about trends and innovation, and above all, similar to what we're doing today, comparing views about best practices and the management of logistics and good practices. And we decided to pursue this challenge about 10 years ago, together with Marco Penaccini. And 10 years have gone by, and we don't want to brag, but we can for sure say that the Observatory is now a landmark for the entire logistics industry. So let's get to the nitty-gritty of our presentation, but let me set the scene for a few seconds. And maybe some of you have already read the end-of-year report. We would like to focus on the past 2 years. We don't want to dwell on COVID-19 and the pandemic, of course, but we're confident enough to argue that the pandemic, about the fact that the pandemic was a potent accelerator of logistic trends. On the left-hand side, so during the first and second spike of 2020, everybody realized the importance of logistics and warehousing facilities. So logistics took up a lot of allure, because we know about logistics whenever there are national strikes or pollution-related issues, etc. So this was a very important recognition that was accelerated by the pandemic. And so on the right-hand side, you see that several projects were piloted. and there was increased resilience of logistical networks and strengthening of logistical processes. In fact, we all work in a digital format, health and safety also, and at the top of the ranking you see sustainability, environmental as well as social sustainability. So, moving on to sustainability, well, our observatory decided to address this topic in a fully fledged fashion, and we decided to investigate sustainability from the environmental standpoint as well as from the social, the economic and financial standpoint. We know that sustainability is very labor-intensive. It's a very labor-intensive effort, and we're pretty sure that this will trickle down also to central warehouses. And we are actually looking at the USA that are trendsetters. And in fact, some of the things that we are witnessing now had already happened in the US 7 to 8 years ago. And this is evidence of the fact that we have to boost the attractiveness of this industry. It is a beautiful industry, very innovative, that really leverages on innovation. Last but not least, these sustainability-related variables must be cross-matched with some economic aspects. The so-called at-all-cost sustainability must be taken into account vis-à-vis the costs of environmental and social sustainability. Sometimes we can come down to trade-offs because there are some solutions that have positive reverberations in terms of budget, but at times we have to perhaps look at the mid to long-term investments-wise. And a few words about the current scenario. We realized, as Gino said, that thanks to e-commerce, we're going to singularize logistics. And so here we have, for example, the penetration rate of B2C e-commerce purchases to 10%. And yesterday, new data was shown, like up to 11%. So it's no longer niche. That's what I'm trying to say. And e-commerce and logistics is more expensive than traditional logistics. So we have 10% in terms of penetration, that is to say at least 20% in terms of value. This is shaking up the equilibria between vendors, customers, suppliers, and logistic providers. And all the costs related to that, for example, power, labor, etc., are indeed on the rise. So let us focus on one of today's topics, that is to say Logistics 4.0. We realized, sorry, there is a loudspeaker's announcement, so should I carry on? Yes, please. Okay, so technology is an enabler of this accelerated pace. Today we'll be focusing on warehouses, and we have an ad hoc project to map out 4.0 logistics solution. On the left-hand side, you see this 3D matrix that takes into account the different aspects of Logistics 4.0, so hybridization, interconnectivity between and amongst resources, I mean man to machine, machine to machine, and also the decision-making process, which is one of the telltale elements of Logistics 4.0. We're bringing intelligence to the field. So this intelligence is distributed across the territory, and thanks to the 4.0 module, this intelligence becomes more decentralized. For fairness, I have to say that this also implies networking, transportation, and these two subject matters aren't on today's agenda, but still we've done really a lot of research, and we've examined several case scenarios regarding regarding digital technologies that expedite digitalization, improved control processes. Let's think about GPS or mobile apps for transporters or those who handle, for example, singularized items or bulk items. And then we have data processing, which is a real challenge of today's and tomorrow's logistics. In other words, we wish data to become literally the heritage, if you will, of this industry. That's why we want to work on data in order to generate value across the board. Looking at logistic buildings and facilities, well, today we would like to show you our 2021 research about the selection of the buildings, design, solutions in terms of indoor and outdoor spaces. We studied innovative warehousing solutions, and this cross-matches with energy efficiency, which is indeed a very topical subject. So reduction of emission, reduction of consumption, and the use of the so-called green warehouses. A few words about Logistics 4.0. Last year we mapped out 275 projects in Italy alone, pursuing Logistics 4.0. 65% on the left-hand side have to do with warehouses, 35% regarding distribution, so transportation of goods. And I'm not going to dwell too long on these, but 37% pertain to automation. And at times, if you think Logistics 4.0, we only think about automation, but that's not the case, because 41% had to do with man-to-machine integration, and 22% the decision-making process, because all of these processes ultimately support decision-making.
Questa è una figura, diciamo così, abbastanza, come dire, qualitativa, se vogliamo, che incrocia.
So this is a qualitative snapshot. On the vertical axis, we see performance and operability. On the x-axis, the timeline. So the S-curve that marks the introduction of innovation, the implementation, and then benefits. Well, you see that 4.0 represents a quantum leap in terms of performance. The type of curve shape remains the same, with an initial phase characterized by dissemination of innovation across the business, benefits, and then synthesis. So 4.0 is pushing upwards. This means that we really saw a quantum leap in terms of performance improvement. In the past 12 months, we focused on some of these topics. That is to say, the introduction and the implementation of energy efficiency projects and Logistics 4.0 projects. It might sound trivial, but the different steps we've mapped out are prone to errors that may be detrimental to the success of the project. Let's start with time zero, which is the definition of a problem or an opportunity. Once again, we must be very crystal clear about why a certain project intends to be pursued. And it's important to discuss with clients. So at times this was the result of an executive's desire, for example, or a fad, or something because it was, fashionable, whatever. So then we have, after the agenda setting, we have the matching phase. That is to say, the possibility of identifying the right or the best suited solution, because you've probably seen that there are hundreds of different solutions. So it's important to identify the one that has the best fitness to solve the problem. Then we have restructuring or implementation. That's a very important a point in time.
Diciamo così, dallo scaffale per introdurre
We can simply buy a solution off the shelf. It doesn't matter whether it is a hardware or a software solution. Such solution must be adapted to the different processes. And this phase is called restructuring, followed by a piloting project. And I've been working in this industry for the past 12 months, and I noticed that several companies go wrong when they reach this stage. So at times it is very important to have a pilot project that can be very agile in order to have some sort of a dry run and then decide to extend it to the rest of the company, hence reap the benefits of it all. So looking at these 5 steps in the process, marking introduction and implementation, we decided to track them in percentage terms. So you see on the left-hand side and on the right-hand side. So the left-hand side, on the right-hand side, in terms of companies, we have 45% of businesses that manage to extend their Logistics 4.0 projects across the whole company, if not across the whole supply chain. Lastly, before discussing energy efficiency projects, I would like to draw your attention to some of the factors that may influence the success of a project. We decided to cluster them up into 4 silos: technological factors, organizational factors, relational factors, and external ones. For each and every one of them, we decided to drill down and see the incidence in terms of success or failure of project design. And in the interest of time, I'm not going to present on that, but you can find the results on our website. But for example, when it comes to technological factors, we need to review compatibility with pre-existing systems, ease of use, and also there must be a certain degree of user experience. And the possibility of developing a pilot project in order to adapt the technology at best. Moving on to the organizational factors, I'm not going to list them all out, but I remember seeing a project that was technologically well designed, but the very same project questioned organizational responsibilities within the company. And so this was labeled as an organizational factor. We always have to remind ourselves that we liaise with people and not machines. Moving on to relational factors. They're not that frequently addressed, but some of these rely on collaboration, so soft skills, and it's very important to work with technology vendors and also with clients on many different fronts, such as these relational factors. And then we have a series of external factors, like the desire to emulate what competitors are doing, and also the acquisition of a competitive advantage vis-à-vis the competition. Last but not least, starting from the transition Logistics 4.0 project, we really welcome allowances, subsidies, or external funding that can foster the introduction of innovation in this industry, because it does have some financial and economic repercussions. I apologize for my speed on the first 2 points, but I don't want it to steal time from Andrea. Andrea, over to you. And thank you very much for listening so far.
Io devo passare di qua perché sennò poi io tanto non sto fermo. Allora, grazie Damiano. Ovviamente quello che avete visto,
Damiano. Of course, what you have seen so far, report 2018-2019, and of course it is know-how when we produce the book that is a digital book now, so we managed to be even greener, but technically we have 11 of them, 11 of these reports, and this year we'll have the 12th report. And inside you see the description of what has been discussed so far. We have a great convergency, so these aspects are part and parcel of logistics that may be linked to one factor, to the warehouse, to the planning, but now it is absolutely obvious to talk about them. This was not the case 10 years ago, so we were among the first to analyze that. Network evolution, after what Damiano said, we have seen some changes, and so we try to work both on the physical part and what is the general evolution, and some aspects such as infrastructures. Physically, what do we have that we're speaking about? Warehouse of something physical, but now there are designs and planning for new trucks, but precisely for logistic structures with this type of organization. Now we are affecting the yard, so not so much the inside of the warehouse, because here we have hydrogen vehicles or electrical vehicles, and here, for example, we have larger yards for this service, in this case for reloading, recharging, and there will be an exponential growth. So these systems will have to cater for many vehicles. So for the time being, we just have this for local distribution. But if we have all that on a large scale, and Europe is moving very fast in this direction, the Horizon program up to 2029, 2030. So we'll have this hydrogen batteries, and there will be implementation requirements. So warehouses must also be centers for industrial recharging of the vehicles, and so that also must be taken into account. This is an example. This is a real design. There are these huge parking spaces. This is a hub, and there you have the electrical vans and also the areas for recharging. Well, the new one, of course, is much simpler, and so this is something we are going to see in the future. OL means logistic operator. At the beginning of e-commerce, we saw that there were separate channels. Now we see an increasing overlapping, because now there are synergies and the systems have overlapped so as to manage this intertwining of things. What do we mean when we say they get closer? Well, some centers are far closer. A city such as Milan and in Rome, maybe things are even worse. And they start. I mean, it's all hangars or abandoned areas become increasingly interesting. Here we have the Ortomercato area, and there was another development somewhere else in the city, because now we must reach the final consumer as rapidly as possible. This trend is linked to e-commerce, but not only, because what we've been noticing is that the different channels are getting more and more influenced through that, by that. So even though it is not longer necessarily B2C, then planning choices. Last year we considered sizes, how the design of the warehouse was impacted, and so on, the height, and so on and so forth. Since we were speaking about how many channels, we must put together automation that is rigid with flexibility, because maybe I don't know what that warehouse will be used for. I don't know. There is a peak of the Black Friday, and then then there is Christmas, but for Christmas we have not so much a B2C, but rather a B2B or a C2C, whatever. And so this has an impact on the layout as well. So we have a handling ability that must be scalable, because that channel may grow, may develop, and we must follow. And then we have a mix of handling units, single item, pallet. But of course, the product is always there. In the past, I remember a warehouse that had the upper floor just for the piece logistics, and underneath you have the box. Now we have a complete warehouse just for the single piece, for the single item. And then there is the size of the order. Whoever works in the B2B, well, it goes down, and the handling area, the picking area, the sorting area are completely different, and the ability to handle depending on different periods. Well, if you have automation, that is defined, and you cannot go back to the provider that saying that he got it all wrong. And then another important area is that also the units may vary, because they are determined by the market, not certainly by logistics or by product design. Let's try and understand what is truly there vis-à-vis the classic oxymorous. If it is automated, it is not flexible. Well, the first example is that we have flexible solutions. Here we're speaking about shuttles, lifts. These are consolidated functions. Here you see examples of a compacted area, and then we have a hung area. And so on standard structures you can manage handling that is far more flexible. Here we have mono and bidirectional lifts and shuttles, and also for hung garments. This is a very dense slide. Yes, we're very good at doing that, actually. On the left, low flexibility, high flexibility, the two are mentioned on the top. So we are speaking about the shuttle. The shuttle is, in fact, the tray or that moves up and down. I can change that during the course of the year, because you see there on the right, we can change the number of shuttles, of lifts. I can make them work more or less, and so scalability. I can start with just a few of them and then increase them. So I can consider both the peak and the increase in volume. Size changes. If I have defined a given box, of course the box can contain different things. I can have a higher flexibility. Of course, the red dot is not so much to the right, because of course you must have a specification, so you cannot move from 10 to 100. And here is the mix. That is the third case. The shuttle gives you also this possibility of changing, of having a mix of the handling unit. It is not a cure-all solution, but it has great advantages, and the same goes for order size. Since you can manage different channels, so that is very helpful, because warehouses must manage different things. So pallet, group of objects, and single object. Then layout and building type. So the prerequisites of the flooring. So managing automation in existing warehouses. No, these are solutions that can be applied also to traditional warehouses where there is a given area of automation, and so there are different possibilities of organization. There are people who have started managing the single unit and well, they were very successful in this change. The e-commerce generated, of course, the robot issue. If you have a look at them everywhere, the one there on the left is Amazon, but there are also different robots carrying shelves. So there was an enormous development. So with this robot that is radio guided or laser guided, or the auto store that grabs from top and then unloads, I mean, all this led to an enormous variation in flexibility. It is important to underline that behind all this there is a huge software work. Ocado in the UK, when they implemented the first real system, took a software that they were using for airplane control, and they adapted it for managing the trays, because of course all these items intertwine but never touch each other. Machine to man, so I bring things towards the human being, and I bring them at enormous speed, being of course extremely effective. Then of course shelves and trays must have predefined characteristics. So I can carry shelves that are not necessarily identical. And here we have shuttles. We have shuttles carrying, of course, hung garments, but also bags carrying different items or boxes. In the past, we used to have on shuttles just hung garments, but now you can also have boxes or bags being managed, being handled by these shuttles. Here you have smart forks or smart trolleys. They have sensors, and they also have the possibility of working with an intelligence that is not only WMS intelligence, but also rapid interlocution also with the central system. They are quite autonomous. There is no man on board, and they are very reliable. I mean, this technology is absolutely right. Of course, you need batteries. They must be reloaded, because of course then you must manage also the time to reload batteries, but these are some pictures showing you that you go from the individual item to huge quantities. So just to look at the best, here you see handling on shuttles. You have higher numbers, better management. Here the size, well, I can put many units one on top of the other, many pallets. I can improve the mix, but as you see the layout, that is the last line, different layouts are possible, and they can be set in existing buildings. So we are working on something that can be introduced in a factory that is just 300 meters. But I can be helpful. I mean, if you think about shuttles, the density of stocks, I mean, if it's just 6 meters, I mean, it is useful to exploit a space that wouldn't be exploitable with different technologies. These are the design choices. Very rapidly now, we are just right with time. So energy efficiency that usually we relate to emissions and sustainability, because essentially the whole issue is linked to the fact that you produce emissions depending on what you consume in terms of energy, or if they are cooling substances you would let in the environment. So the two things go hand in hand. If you reduce consumption, whatever they are, with a similar mix, you also reduce emissions. So this is the essential scheme, since we all are in love with efficiency, because it is a win-win solution, both in the environment and the cost. So we started speaking about efficiency. We have put together all our research in this area. We have about 3 million square meters. and more than 120 warehouses in all sectors with different years when they were built. So we will be carrying out this, we have been carrying out this research. We have identified solution families, 6 of them actually. There are some of them that are in darker colors. I mean, you see heat, green building. So here we have thermal isolation, green roof, not only cool roof but also green roof. So not only a reflecting roof but also a roof with some insulation, so natural cooling. Then lightning, there will be people speaking after me. Then material management, what type of warehouse, I mean reuse, recycling, if it is a bio-based material or not, considering the type of impact, the level of climate, also the waste that may be regenerated. Then utilities, reuse of water. When you do an environmental report, normally you speak about the CO2, wastewater and biodiversity. So water is always present. Here I can use water coming from wells, recycled water, rainwater, water from the mains. Then handling and automation, new technologies, hydrogen trucks are being sold, are being used, hybrid fuel and battery trucks, then the most consolidated, and ion lithium batteries and high-frequency battery charging. And you can do without technology by optimizing the organization. You can get very good results because if you have less man time, less consumption, if you reduce, let's say, the kilometers run by the single machine. Then operational strategies. Some examples of green building. You can work on panels, of course, on loading point, and then the green wall. Here are 2 examples. I was there this morning, and it is really there on motorway A7, because they have been improving the visual impact, but also with a good impact on insulation or the effect of being exposed to the sun in a given way. This is as for design. And here color white. It may seem trivial, but if you paint something white, you increase visibility and you decrease consumption, and a dedicated area for waste that are also easy to manage. I stop here. I spoke very fast, but now I give the floor to Andrea Martini for the area of lighting, and electricity, of course, has a very important role to play. Thank you.
Mi sentite? Sì, mi sento anche. Buongiorno. Buongiorno a tutti, grazie.
Good afternoon, everyone. Thanks very much. Thanks very much for your kind introduction.
Grazie. Grazie anche dell'ospitalità.
Thanks for having me.
Da parte dell'Osservatorio, dei suoi direttori, grazie mille.
Thanks to the Observatory, to the chairs, and this is a wonderful opportunity.
Perché insomma l'efficienza energetica è una
So I represent Trilux. Energy efficiency is indeed a win-win scenario. Some slides of the research we made weren't shown, but I think that one of the slides that I recall very clearly showed a matrix explaining that the use of sensors was one of the measures put in place that feature the highest value-added potential with the lowest possible spending. Many people talk about LEDs. We are also using them, and there are different sorts of LEDs. And so the scenarios are multifaceted and can be very, very diverse. So what really makes a difference between a green, and thank you for giving me the heads up with the microphone. Sorry. So what are the differences between an approach, a green solution approach versus a traditional standard solution? Well, first of all, the choice of the client. The client intends to implement a project that will be valuable in the short to mid-term. This obviously might have repercussions in terms of payback times, but there must be the desire and the willingness of pursuing green objectives. In fact, we know that green economy and green sustainability is not a fad, but it must be a pursuable objective. By this I mean that if we really want to be green, we must be able to recover architectural facilities in the best possible way. We have to work on building envelopes, and we have to adopt flexible technologies. Sorry. Sorry for the microphone. But if the indoor facility is or space is unhealthy, you see that this is bound to be a failing project. Or using cutting-edge technologies that can only be controlled by software, you see, we are not really hitting the nail on the head. So there must be managers and executives capable of making mid to long-term decisions. Sorry for this introduction, this lengthy introduction.
Uno di questi interlocutori di cui
one
abbiamo avuto l'opportunità di affrontare è stata con DB Schenker in questo
of the client we worked with is DB Schenker for this facility. Why DB Schenker? Well, DB Schenker isn't a giant warehouse, but still it represents the desire to pursue a certain type of objective. And so we had the opportunity of working on multiple fronts. So I'm going to put the hat of my engineer's hat. So again, flexibility. And you see, in fact, that we have wood trusses here. So it's very roomy, and this space can be freely used. And oftentimes these facilities are owned by one owner, but they're used by different actors, for example. So it's very important for this building to be flexible over time. That's indeed the trump card. Many of you have already heard about LEDs, LED solutions, and you know that LEDs have a very long life, like 40 to 50,000 hours on average. In this case, the client, together with us, decided appliances that last for 70,000 hours. And this doesn't mean that they simply shut off after 70,000 hours, but they just emit minus 20% light. So if they're well set up and positioned, after 10 years, you still have a system or an appliance that is still new, if you will, but you have to think about all that a priori by way of briefings, for example. And this does not imply a huge investment. We're not saying that this is 3 or 4 times as much what one would spend for a traditional setup. And I'd like to really emphasize the timeline. So we don't have to be pursuing a green philosophy just because that's a fad, but because it is an intention. Having a flexible system for, say, 10 years is very important, but you have to design and plan in the right possible way. It means flexibility. It means operating the appliances up to 70% of their potential. So, and
mettere in condizione, come succede in questo caso,
as in this case,
è dotato di un'intelligenza interna che
the equipment has internal intelligence that returns important information. So the solutions receive infos and return information like, look, I'm functioning, I've reached 80% of the cap, or alert because the temperature is rising, or I'm off. So these are all the prompts, so these are all the threads of data that can be generated digitally and stored in the cloud platform and made available to the client, who can use all these infos for predictive maintenance. In other words, to be proactive and to schedule maintenance procedures. So, in short, this is a system that provides us with valuable information. It may look like science fiction, but it isn't, trust me. And the beauty of it all, from our perspective at least, is that it is scalable, and the possibility of scaling it up is crucial, and this is one of the key words that we kept repeating today. So we might have the best possible system that runs smoothly. I have information that I can use at a later stage, or I may want to analyze data for the first 3 years of activity and then stop. Or I may want to use certain types of appliances and then revamp them after a few years. So in our opinion, this is a green approach. This is an efficient win-win approach between the client and the provider that decides to invest on a long-term philosophy. In this case, the client decided to imagine or to envision what was possible. And the combination between lighting and sensors can result in an 80% energy saving, which is nothing to sneeze at. Another important slide, which wasn't shown today, described that the energy for lighting purposes accounts for 44% of the whole electricity volume required by a logistic building. So if you save on lighting, you end up saving 50% of your cost. Does it does it reconcile with you? I guess so. So we decided to focus on energy consumption as a win-win solution. The adoption of solutions that really go beyond mere energy consumption in order to be BREEAM certified. BREEAM certification is important. Actually, it is increasingly important also in the domain of logistics. This is a current trend that we are measuring today. It could be CBC, BREEAM, or you name it, but still we are really going towards a very frequent use of certification. So in other words, you end up saving in a very well-oriented fashion in terms of well-being and cost containment. And we have some lovely pictures here, and you can check them out in our blog if you like. But you see that there are solutions for outdoor spaces, for indoor spaces like office space, and also for intralogistic and logistic facilities that make it possible for you to save energy, to foster staff well-being with utmost flexibility. And all of these solutions can be scaled up over time. And we believe this is the ultimate goal that should be pursued.
Qui stiamo parlando di un edificio nuovo.
This is a brand new building which was built from scratch,
con le altezze giuste,
with the right heights, with the right standards, etc. However,
di Fossa,
Mr. Fossa's mentioned the possibility of recovering pre-existing buildings using white walls, insulation solutions, etc. And so what are we going to do with what's inside these buildings? So should we replace old lamps and put up a new lamp and just keep the wiring of the cabling that date back to the 70s or the 80s? Well, not necessarily so, because it might be high time for you to reconsider the wiring and the system as a whole. Because, you know, frequently enough we may recover and refurbish some like pre-existing facilities, but still we have to bear in mind that we have to make a technological leap forward, and this can only be done with the right utilities, the right system, and the right design and planning. And I would like to borrow this example from another industry other than logistics, and I'd like to show you this video. This is the example of a municipality. Okay, here is the video. This is a parking lot. In 2 or 3, 4, 5 years' time, whatever, this is probably going to be a logistic building where there is a savvy entrepreneur that decides to revamp the utilities and the systems to cut on energy costs, to cut on maintenance cost, and the decision or the appointment of the contractor will be based not only on economic and financial considerations, but also bearing in mind the desire and the willingness to create economic circularity. In this case, we have very old wiring and cabling, old lamps, forgotten efficiency, and the municipality decided that they simply wanted to refurbish and renovate the area. This is the contractor and the owner of the contracting company that was appointed. You see the old appliances that were removed, were taken to a specialized facility to separate the various components. And this is exactly what this foreperson is doing. So the lamp on the side, plastics set aside, and first of all this made it possible to recycle, for example, steel, plastic materials, etc. This is my Dutch colleague, and we decided to go the extra mile because we took the shells of these lamps and we cut them through, we shredded them, we created this sort of plastic powder, dust, and which was used to create the base of the new lamps used in the new parking lot. So in other words, the old appliance that was dismantled sort of was converted into a new product thanks to new technologies. And why not? Maybe this could also happen in logistic buildings. So this is our wish. I'd be happy to take any questions, if any. Thank you very much.
Sì, il messaggio non è proprio subliminale, cioè ormai si sta lavorando su
Well, in fact, we are working not only to create efficiency in terms of cost. The Schengen case is very clear. So carbon neutral warehouses, so this is, you don't have just to buy green energy, but also a circular approach of the system, of the plant, of consumption material. There are many aspects a very old analysis said these Italian warehouses could be, I mean, the soil could be freed very easily. They were not so bad from the green viewpoint. In Northern Europe or in the Netherlands, I mean, it's all cement, and then they put iron on top, but the rest of it is not prefabricated, but it is concrete. Thank you, Damiano said. Well, we try to call companies over because the things that have already been done are the things that give us ideas. Just to give you a couple of extra ideas, you see here, we try to understand how our panel of companies, of managers, but we also have the possibility of carrying out service with a large panel of companies. Here are the two colors. We have two bars. On the right, it is the what we foresee for tomorrow. So the expectation for roofs, for example, is the same. The same goes for handling. Lithium-ion batteries are important also for buyers, not so much for suppliers. But see on the right what is for the future, hydrogen and hybrids. So we are moving in this direction. Doesn't mean that they are already existing, but it's something that is going to happen in the future. Here is packaging, biological material. There again, there is an evolution. Here, the customer is very powerful with a number of suppliers, including logistics. And here is precisely what we were discussing before, high impact, low difficulty of implementation, because now they are very, very popular, whereas there are all the other families. This is a focus group, is not a quantitative research. So in this diagram, we see that on the horizontal axis, from low to high difficulty at implementing. You see hydrogen, for example, you need a plant, and the impact generated. We would like to give also quantitative figure data, and this is one of the challenges for the future, because we'd like also to guide this transition both on what has already been installed and what will happen in the future. This is the general approach. This graph may seem very simple, but when on our panel we saw many installed solutions, there are 3 columns, they up to 5, from 6 to 10, from 11 upwards, and we have seen values. The numbers you see are kWh, you see, but the average is interesting, and the division, well, light blue control temperature and ambient temperature. The more you move to the right, the more the number decreases. So also from a numerical viewpoint, as a famous chicken average, there is an impact. So now we see numbers that confirm that the solutions of energy efficiency can be seen in the real performance of the plant. Well, the numbers are not enough to create subgroups and families, levels of automation, temperature, refrigeration. I mean, not all data are positive, but we start seeing this trend, and the field data confirm this approach. We've been working on that. Why is it fascinating? Because if we reduce the consumptions with an equal electric mix, we also improve climate impact. Well, even just speaking about electricity, the ambient temperature is very high. We may go even over 50%. Then handling, and then refrigeration, And of course, you have to feed refrigeration as well. Here we're speaking of the final impact. The 3 large families to generate an equivalent CO2, electricity, fuels, and refrigerating substances. For the refrigerating substance, we use reloading or recharging. If we're using different type of conditioning machines, glycol, kilo per kilo or per liters, you have an equivalent loss in the system. Here is the consumption part. Electric energy accounts for 87% for electric consumption versus 13% of fuel. So it's clearly prevailing. If you have the same figure for Northern Europe, the fuel accounts for much more because it's used for trolleys and many other things. On the right, the fuel split, essentially natural gas. As for electrical consumption, on the left, about 1/3 in our panel is made up of a renewable source, apart from the national mix. Our national mix, anyhow, is not bad. It's over the European average as for renewable energy. And on the right, the source, renewable sources, photovoltaic plants, and self-consumption. And so, of course, those who have a photovoltaic plant at present can consume their own energy. In that case, energy efficiency, well, of course, you have an immediate advantage in consuming your own energy, the energy you yourself produce. Here are the percentages also on a time scale, ambient temperature for the years. You see the percentage of lighting, handling, and cooling, refrigeration have moved somehow. So if you have a warehouse at ambient temperature, well, if consumption is 100, this is the type of match you can use. Then we do that. Here you have ambient at the same temperature, where positive, controlled, and negative temperature. You see the impact on refrigeration of electrical consumption. There we're speaking of refrigerators, and that is very high. These are historical averages. Now we have reference values, and we'd like to have these values as international benchmarking. Then emissions. 3/4 of the emissions are generated by electrical energy. Then we have fuels, and then refrigerating substances. This is our mix, and if we consider electrical consumption, we try to subdivide them. Handling, lighting, well, they mirror consumption. And now I stop here, and just one case, one warehouse, and now we give the floor to Fabio, who will be sharing with you their experience. He's the facility manager.
Buongiorno a tutti, io sono Fabio Brisichella, sono il facility
Good afternoon,
manager
everyone. My name is Fabio Brisichella. I'm a facility manager at Brivio and Viganò. And I'm here today to share with you the user's experience. We've heard the experience of trilogues, and I'm here to represent Brivio and Viganò, a company who made specific decisions during design and planning in an attempt to enhance and boost our properties, especially with regards to the site in Pozzuolo Martesana. This is a facility that we set up a few years back, and it was originally designed with a sustainability DNA at the back of our minds. Brivio Viganò works in logistics, and we date back to 40 years ago, and we work in the fresh and frozen logistics processes, and these activities are characterized by high energy consumption. There are approximately 2,500 employees, over 800 vehicles, and over 250,000 square meters in terms of footage. And we're present across the whole country, Lombardia, Usmate Velate, Pozzuolo, Piedmont, nearby Nichelino Viandrate, with hubs distributed across the national territory, with a site in Pomezia as well. So let's talk about our most recent project. We will talk about the tri-generation power project, how we managed to optimize our process in the past 3 years, and what we're currently enacting in order to improve energy consumption across our buildings. The Pozzuolo Martesana hub is comprised of approximately 29,400 square meters, and we have the so-called fresh areas, 0 to 18 degrees, and frozen, minus 25 to 18 degrees. The entire building is made of PIR materials, and we decided to divide the building up into multiple cells for cooling purposes, hence the possibility of adapting to customers' needs and to go from fresh to frozen and vice versa. And the other decision we made in terms of environmental sustainability was that of having a plant which is powered by ammonia and CO2. We use natural gases, and the characteristics of ammonia are quite clear because it's flammable, and CO2 instead brings with it problems related to saturation when at room temperature, and so we decided to deploy a series of improvements in terms of consumption reduction and efficiency. So let's have a look at the tri-generation project. We were in the process of reviewing the use of a photovoltaic system as in the hub of Usmate Velate, and we opted for a tri-generation plant because we had to create 9 megawatt per hour per year, and this was not compatible with photovoltaic networks. This system is powered by ammonium hydroxide, and thanks to the release of these megawatts, we can cover entirely the needs of our facility. And when this tri-generation, so not only the combustion of methane, but also recovery of warm fluids on a daily basis, we can recover approximately 1,000 kilowatt per hour of cold energy that can be used for our refrigerating cells. The system has an absorption unit inbuilt that uses the warm fluids that comes from combustion for the production of electricity. We're talking about 88 degrees, and after the absorption unit, this goes down to 78 degrees. And you will see later how we try to improve this circuit even more. This is the graph that charts our consumption curves throughout the year. In summertime, you see that there is a spike. In blue, we have power production by the tri-generation unit with regards to power for the most part. In July, during a maintenance week, you see that there was a drop in production and an escalation of costs. So in assessing the optimization of the entire system, we will have to shift these activities during the cold season because the cost is extremely high. At the bottom of the chart, you see the transformation of cold kilowatts into power kilowatts by the absorption unit. And this is very useful because it compensates what's needed during summertime. Then let's have a look at process optimization. We realized that hot fluid at 78 degrees could enable us to push our frozen activities even further. When the refrigerating units that push cold air at minus 25 degrees into the system freeze, we have to defrost them by using a hot liquid that melts the ice. Usually this is 22, 24 degrees. If we manage to increase this threshold, we can improve the efficiency of these machines. How to do that? Well, first of all, we can use external machines that are powered through an external source, but this was costly. So speaking with our suppliers, we decided to use a heat exchanger that traps the 78 degrees area, cuts it down to the 83 to 78, so that this goes down to 30 degrees. And by doing that, we managed to improve our efficiency without incurring into any costs by using a waste liquid product, hence producing frost. We are translating this onto the cleaning of our dryers, because we have to contain humidity, and so with the same system we will succeed in regenerating the dryers that are used for air. We decided to go the extra mile, so much so that we are in the process of considering the implementation of photovoltaic plants in Pozzolo Maltesana. We have approximately 30 kilowatts that basically feed all the office spaces, and we would like to bump it up in order to bridge the summer gap. This is very advantageous because we can put the power back into the grid thanks to the dry generation unit, and in other words, we will have power that is produced at literally zero cost. And then we are also working on system efficiency, and we are quite far-sighted in this regard because our engines are asynchronous engines. Some of them are equipped with an inverter. We are now considering the possibility of using synchronous engines with permanent magnets, and this is a known technology that is burdened by several limitations, especially during the startup phase. However, this will enable us to have a yield that fares around 8%. And by doing that, we will be able to reduce maintenance costs significantly. In addition to facility management, we are also contemplating sustainability across all of our projects. In Usmate, for example, just to give you an idea, we have a 400 kilowatt photovoltaic system, and we have fresh storage there. With towers, external towers, chillers, and these are external chillers, and they are air-powered. At the Usmate hub, we located this vendor called Turbo Algor, that works on refrigerating cycles. Lamination is the weak point of the cycle because of high costs. Turbo Algor is an application that cascades from the automotive industry. Maybe you all recall Fiat Turbo. Anyway, they took the turbo of the old Fiat 1 car, was put into the system, and through the transformation from liquid to gases, we can increase the pressure into the chamber and improve the overall efficiency of the system. We're also pushing not only in terms of facility management, but also on our fleet. In our fleet, we have 4 vehicles, LGD powered vehicles, and we are also considering hydrogen. Lastly, another important activity we are performing on our fleets is to implement in our workshops a control system for the axis of a truck. Whenever this is misaligned, obviously the wear and tear of the wheels is more massive, and this orientation makes it possible to realign the axle when the vehicle drives through. And this is very important for our fleet and also for the fleet of our vendors. We will be checking out all of the Brivio Viganò trucks and vans, and also all the vehicles that will transit through our area, in order to reduce these consumption contingencies that will trickle down on society, in other words, and so in order to safeguard and protect the environment. Thank you very much for listening. I'll be happy to take any questions, if any.
No, molto interessante. Qua vado bene, no? Perché mi hanno detto che...
Fascinating, fascinating.
Come avete visto, si sta muovendo. Io prima si evocava.
Well, things are changing. Here, that was very clear. One must start working at 360 degrees. Now, I mean, I'm very glad you're doing all that. I missed a few things, but there are many pieces. But the real issue, when you saw that graph, there were so many solutions, but we are still mapping all that, because we have seen that also considered the complexity of the plans. People want to understand how things are doing, and there are companies who are very brave and move forward very fast. And if you, it's only by making some small mistakes that you learn something more. I've mentioned that we are working now at the international level, and this is a project, this is a 3-year project that we are carrying out with international partners from after ELM and material handling, and the Sanders University. We are involving the Cranfield University in the UK. So we are studying the warehouse of the future. So we are contributing with the logistic system, warehouses, and so on sustainability. And the idea is these objectives, finding the best practices and requirements, what are the future specifications. So we are working both in terms of research and also conceptualization, but also methods. What is the interest of having a sustainable warehouse with these specifications? The interest is high, but we must also be able to measure how high. We want to do that at the international level, and we want to do that also with the possibility of a general approach. So a single site, having an assessment of the single site, but then within a single site, also managing to separate. So this is the objective, having that at the international level and managing both the classic logistical site and also the terminal part, be them a rail terminal, shipping terminals, whatever. The essential thing is that we're doing that at the international level. And this is the first result. The numbers you have seen so far, 3 million square meters. These are put together with a flown-off number, and we have benchmark data for Europe, and we call them intensity factors, equivalent CO2 per ton that has gone through the plant. There are 3 lines: transshipment, storage, and transshipment, and warehouse for the 3 columns: ambient, chilled, and mixed. And the values you see in parentheses, the figures referring to the sites that have given us the numbers. So of course the scientific quality depends on the sample. But they've been used in these 200 sites. We have some 72 of them that are our sites. These are used for the new values for the framework plan. This is the most advanced protocol for calculation of CO2 in transport and logistics, and we will have an ISO norm that is already a draft, and that will be published by the end of the year. That will be the certification benchmark. Protocols were mentioned, the BREEAM and the LEED that include all forms of complexity, but that is really vertical on CO2. So there are values there, and we are in that stream, and whoever is here and would like to contribute, we'd be delighted to map your warehouse, of course, with a very long questionnaire you have to fill in, but also supporting you, because by doing that, we can be in the forefront of this evolution. These values were published in February, and they are included in the plan because the researcher is the head of project for the warehouse part for this ISO committee, the German ISO committee that launched this initiative. And of course we're very aggressive on that because the aspects we mentioned, there are economy, efficiency aspects, but also enhancement, because when you see that curve that goes down for kilowatt hours per square meters, well, if of course the consumption is lower over the year, maybe the flat is more valuable. And so I close with this scenario. Of course, you are all welcome here. We are here to answer your questions. Thank you very much for your attention, and I apologize for putting together everything in just 1 hour and a half, but you'll have time to read our reports at home with plenty of time. Thank you.